We all know that some dinosaurs were feathered, but feathers don't preserve in the fossil record. So how do we know that? Well, one very good piece of evidence is preserved in these rocks right here. And it comes to us from the same formation where we found our duck dinosaur. This rock layer is called the Morrison Formation. It dates to about 150 million years ago. That's in the middle of what we call the Jurassic period. These are mostly just regular old sedimentary rocks, sandstone and mudstone, the kind that you would expect to see in a river environment, just like we have here at Ghost Ranch. But this particular rock has something really cool preserved inside of it. It's got this big imprint in here, almost like a footprint. But it's not a footprint. See, there's no toes here. Instead, it's got claws. 4 claws. Kind of spread out like they're on a hand. Now, if you look closely, you can also see a couple more smaller prints right here. Those are actually from another animal that was scampering around in this riverbed. You can even see part of its tail here. We've got a little lizard running away from whatever left this large handprint right here. These kinds of tracks are called trackways, and they tell us about how animals moved around the landscape. They also preserve in other places, including in the famous Ghost Ranch, New Mexico, where there's an entire museum dedicated to them. So who made this handprint? Well, that's actually the subject of a lot of research right now. There are 2 possibilities. It could be related to our duck dinosaur, or it could be related to this guy. Yep. This is another Hadrosaur. Now, this one isn't a duck dinosaur, but it's pretty close. It's called a Hadrosaur. It means heaped up lizard. We'll get to why they named it that in a minute. But first, let's talk about this print right here. A long time ago, people thought that this was a footprint, but footprints don't usually have claws. See, claws aren't very good for walking on things. If you've ever tried to walk on your fingernails, you know what I mean. They're great for grasping things, though. Claws aren't going to leave an imprint like this. The bottom of this foot is too flexible. If you take a look at this print, you can see that it's much more like the hand of a bird than the foot of a dinosaur. See, this looks like a hand because the metacarpal bones are arranged just like they are in the hand of a bird. Even the individual little bones of the fingers are in the right orientation. Hadrosaurs are definitely dinosaurs, but they're not birds. And dinosaurs typically have flat feet with claws that are better adapted for gripping and walking. This handprint doesn't look anything like the footprints of any known species of Hadrosaur. So who made this? The 2 leading hypotheses are that this was made by either our Hadrosaur friend here or one of their relatives. And it helps prove that these dinosaurs could do things that we didn't think they could do, like flapping their arms and maybe even flying. You might be wondering, how does a footprint help us understand flight? Well, one of the most important features for understanding the evolution of flight are feathers. But unfortunately, feathers don't preserve in the fossil record. They're too delicate. They fall apart way before they turn into fossils. So we don't often find feathers on dinosaurs. But feathers are really important for understanding flight, so scientists have been looking for other clues. And the shape of these bones gives us a big hint. This bone is called a metacarpal, and when it comes to handprints, it's the part that makes the palm. In a bird, this bone is really short, and that allows them to bend their fingers back like this. They've got lots of flexibility, and that's what they need for flapping their wings. If you look at this bone from a hadrosaur, it's shaped more like a paddle. There's no flexibility here. These guys couldn't bend their fingers back, so they weren't really great for flapping. But if you take a look at our mystery print right here, it's got metacarpals that are just like a bird's metacarpals. And that means that this dinosaur could bend its fingers just like a bird can. It could have been flapping its arms. Now, obviously, it doesn't prove that it was flapping in order to fly, but it sure does look like a hand adapted for flapping. Another thing about birds is that they only have 3 fingers. Their hand looks like this because they've lost 1 finger. Dinosaurs, on the other hand, typically have 3 fingers and then a thumb. So this is called a quatrefoil hand. Our mystery print doesn't have 4 fingers, though. It's got 3. It's kind of in between a bird and a dinosaur. Now, scientists are still working on figuring out exactly where this fits in the family tree. But this hint tells us that whoever had this hand wasn't like most other dinosaurs, and they were probably pretty closely related to birds. There are a few other pieces of evidence that help us figure this out too. For example, we know that our duck dinosaur was great at running. It had long legs and feet that were really good for chasing fish. But running isn't the same as flapping, and it turns out that having long legs and feet is actually kind of bad for flapping. See, this is a bird that can't run very well. It's kind of clumsy on the ground because it's got these really long legs. Birds that are good at running tend to have shorter legs, like ostriches. So having long legs was kind of a liability for our duck dinosaur. It doesn't make sense that it would have evolved to have hands that were good for flapping, unless it needed to flap in order to get off the ground. It needed to be able to fly. And that's not all. There's another clue hiding in plain sight. Remember how I said that this dinosaur was called a hadrosaur, meaning heaped up lizard? Well, that name comes from the shape of its head. Look at this guy's skull. Can you see how it kind of looks like a duck's bill? It's got a wide, flattened bill. Well, it turns out that a lot of dinosaurs had bills that looked like this. It's a type of bill that's great for crushing plants. And these guys were plant eaters, so it makes sense. But bills like this aren't good for flapping. In fact, the only dinosaurs with bills like this that we know could fly are these guys, the Microraptors. And they were kind of small, like the size of a crow. Our duck dinosaur was the size of a grizzly bear, and it had a bill just like this. So it seems impossible that it could fly, except maybe it could. Maybe it could flap its arms like this guy and glide through the air. If it ran up a tall hill and jumped off, it could cover a whole bunch of distance and maybe even steer itself while it was gliding. It's hard to say without seeing it happen. Now, we've seen other large dinosaurs that can't fly, like our sauropod friends, try to glide. It's not really a good strategy. They're just not built for it. But maybe our duck dinosaur was different. These hadrosaurs lived along rivers, and rivers are full of fish. Fish are fast, so our duck dinosaur needed to be fast too. And being able to run and jump and flap might have been useful for catching prey. All these adaptations might have come together in a sort of super chase, where our duck dinosaur would chase fish up onto land, jump into the air to catch them, and then glide back down to the river to eat its dinner. Now, we don't have any fossil evidence for this, but it sure would explain a lot of the traits that we see in the fossil record. Until we find more evidence though, all we can say is that this dinosaur had hands that were perfect for flapping, and maybe it used those hands to catch fish. Thanks so much for watching. If you like learning about this dinosaur, you can learn more about all the other dinosaurs on our channel. Just search for Dinosaur to find out more about the duck dinosaur. Or if you want to support our work, become a member on our website. Members get access to behind-the-scenes clips like this one of me flagging some rocks. I'm not very good at it, but you can see that these rocks are full of fossils, which is pretty cool.